Hello, everyone. Welcome back to Reimagine version 11, our virtual conference series, bringing you nothing but the best projects, bright minds, and leaders in the space with a focus on what's up next. And up next with us today is Dominic Williams, founder and chief scientist at DFINITY, the foundation responsible for building the internet computer, backed by investors like Andreessen Horowitz and Polychain Capital. Since Genesis in May, Internet Computer has already deployed dozens of decentralized apps and now turns its focus towards Bitcoin integration. That seems like a tall task, doesn't it, Dominic?
Well, we've been going for a long time. So, the project was working in 2016, being incubated by this company called String Labs in Palo Alto. It then sort of spun out as a foundation at the end of that year. It raised money in a public fundraiser. So it's actually members of the public who are by far the biggest holders of the ICP token. That decentralized fundraiser was run in February 2017, so it actually predated, all of that ICO craziness that kicked off that year. And it's a very different project. I was originally inspired by the world computer vision that was floating around the early Ethereum community in 2014 and 2015. And when I heard about this idea, I thought, this thing just has to exist. The world needs a world computer. It sort of completes the functionality of the internet, if you like. And I also realized that, smart contracts are a really very profoundly new kind of software or system. It's something in between. That run on a public network, and they're tamper-proof. Don't need firewalls to protect them. Unstoppable. Can be composed in the form of components, and allow for tokenization. So, I believe that if we could build a real-world computer using a blockchain that ran at web speed and had infinite scalability and was incredibly efficient and could serve interactive web content directly to users, that eventually, because of the superiority of smart contracts over traditional IT platforms, eventually every system and service would be rebuilt on blockchain. Now, to create a world computer, I realized we'd have to do a lot of very hardcore R&D. So we built out the DFINITY Foundation, and we have by far the biggest R&D. We run by far the biggest R&D operation in blockchain, and it's been running for many years. People often think the Internet Computer is a new project. It's actually one of the oldest. It just took a lot of R&D to get it into production, if you like. And I think we probably employed the biggest team of leading cryptographers in all of tech, not just blockchain. So we have this big team of leading cryptographers, also many computer science researchers and senior engineers. Most blockchain projects, are sort of 80-90%, social media people, marketing people, business development people, and you just have a few hackers who sort of take some technology off the shelf and get something up and running, right? There isn't really that much technical substance, and it's really about building a community and getting people excited and sending the token up on exchanges and things like that. The Internet Computer is almost the exact reverse. We're mostly composed from, cryptographers, computer science researchers, and engineers. So, I describe the organization as blockchain maximalist. We want to see a blockchain singularity where everything runs from blockchain, and the Internet Computer is our way of achieving that. Now, back to Bitcoin integration. The Internet Computer was made possible by the development of new types of cryptography and cryptography framework, which are sort of loosely referred to as chain key cryptography. And chain key cryptography is a pretty complex field. You can go to the DFINITY.org website and go into the How It Works section and access some of the low-level cryptography and sections on the non-interactive key, DKG and key resharing and so on. But essentially, chain key cryptography is used by the Internet Computer Network to scale. And what it does is allows blockchains to be given their own public key, essentially. So, inside the Internet Computer Network, there are numerous subnet blockchains, And one of these subnet blockchains is a master subnet, and it has a single master chain key, of like a public key. And each of the other subnet blockchains also have, their own chain keys that are signed by the master subnet, which runs something called the network nervous system. Now, what's so cool about this thing is that the blockchain is able to act as a whole to create signatures for its chain key, right? Just like if you've got the private key corresponding to a public key, you can create signatures that people can validate using the public key, right? This is the sort of one of the fundamental building blocks, of course, of blockchain. The advance the internet computer introduces is that the blockchain actually has a master public key. So what's extraordinary about the internet computer is there is a single master chain key. You can think of it like a public key, and the blockchain can act as a whole to create signatures against that. So, intuitively, you might be able to see that this makes it possible to interact with the blockchain without having to download all of its blocks, right, into a local node, because the blockchain is signing your interactions with it, and you can just check these signatures to verify that the state of the blockchain is correct and that your interactions with it haven't been tampered with. And inside the internet computer network, all of these subnet blockchains are able to directly interact with each other without knowing each other's state, because they can just check the signatures, right, correspond to their chain keys, and of course that the chain keys have been signed by the master chain key. So it really is revolutionary technology. Now, without getting into the gory details of how chain key cryptography works, because it's a very complex field, and even I myself don't profess to understand all of the low-level cryptography involved, and that's why we employ many of the world's top cryptographers. But that same framework, anyways, is being extended so that the internet computer blockchain can create transactions, firstly on Bitcoin, and later we'll look at other blockchains like Ethereum. Now, what does that mean in practical terms? It means that smart contracts on the internet computer blockchain are going to get their own Bitcoin addresses, right? And this is nothing to do with bridges or wrapped Bitcoin or sidechains or any of that kind of malarkey. These smart contracts will effectively sit on the Bitcoin blockchain with their own Bitcoin addresses. And they're going to be able to send, receive, and process Bitcoin. And behind the scenes, of course, what's going on is that, if a smart contract on the internet computer wants to send some of its Bitcoin, for example, to your Bitcoin wallet, right, to any standard Bitcoin address, or to another another smart contract on the internet computer blockchain. Behind the scenes, in the protocol there, a whole load of super advanced cryptography is going on, and the internet computer blockchain is actually creating Bitcoin transactions to make all this stuff happen. Now, what's so exciting about this is that on the one hand, people building DeFi on the internet computer will, or for example, SocialFi or GameFi or anything like that, these emerging, in these emerging areas, will gain access to the, I don't know what it is currently, $1.5 trillion of Bitcoin liquidity. And in return, Bitcoin is going to get smart contracts. So it'll provide for people to build a sort of new generation of native DeFi on Bitcoin. And just to be clear about what I'm talking about, this means that smart contracts will have Bitcoin addresses, and when they send Bitcoin to other smart contracts or any other Bitcoin address like a user wallet or an exchange, that Bitcoin's actually going to move on the Bitcoin blockchain, which of course is completely different to the situation you see today where, various bridges, trusted third parties will create wrapped Bitcoin for you. And that's a very dangerous arrangement, of course, because, for example, if you want to move your Bitcoin onto Ethereum in the form of wrapped Bitcoin, you've got to go to some trusted bridge and say, here, bridge, take my Bitcoin. And the bridge then, takes your Bitcoin and gives you wrapped Bitcoin on Ethereum. But they're acting as a sort of, issuer and redeemer. and they're holding your Bitcoin in custody. And, you rely on the fact that when you want to go back from wrapped Bitcoin to Bitcoin, that bridge is good for its word, right? And if they get hacked, all the Bitcoin's going to go away and your wrapped Bitcoin will become worthless. And we've seen, these bridges get hacked already. I mean, the Poly network got hacked for $600 million a few months ago. The hacker involved very kindly gave back all the different, Bitcoin and Ether and everything else that he stole, which was very kind of him. But, sooner or later, we're going to see a Mt. Gox type event where, all of these kind of chains, like, that have all these wrapped coins, are going to experience something nasty where the trusted intermediary that's the bridge is going to run off with it. So there's a very big difference between smart contracts on Ethereum or Avalanche or Solana, say, processing wrapped Bitcoin, and native smart contracts on the Bitcoin blockchain. So I think it's incredibly exciting. And I mean, for me personally, obviously I'm very passionate primarily about the technology, and we've been working with the whole chain key framework for years now, and it wasn't something that was we were able to do quickly at all. We're pretty much the only project in blockchain that actually develops new cryptography to solve major problems, and we're the only one with the capability of doing so because we have the necessary expertise. But developing new cryptography is very time consuming. Integrating some of these super complex cryptographic techniques with blockchain protocols is very time consuming. But we've got there the internet computers running using chain key cryptography, and now we're extending it to support so we can essentially directly integrate the internet computer and Bitcoin networks. And it's going to be great for both networks. Bitcoin's going to really have the ability to create native Bitcoin DeFi. And there's a lot of very interesting things being built on the internet computer at the moment, in areas such as SocialFi and GameFi, for example, that they're going to be able to make use of Bitcoin.
Yeah, because the number one, I think, way that I've heard the layman kind of describe internet computer is, they're trying to wrap all of the everything else. And digging a little bit deeper, it seems like what you're describing is a blockchain of blockchains where...
No, well, kind of, yes and no. Look, I mean, one of the... if you look at one of the reasons DeFi has been successful on Ethereum, is because all the smart contracts exist inside one trust zone, right? Within one seamless universe. Like if you run a DeFi smart contract on Ethereum, I can upload a DeFi smart contract on Ethereum that with permission calls into your smart contract, right? There's no interoperability cost. It's all just code within one universe. And this creates immense network effects because you have system composability, right? You can compose new systems from existing system building blocks, which are smart contracts, which are sort of like double as both software and system units at the same time. And one smart contract can simultaneously be in any number of different systems. And it really is makes smart contracts generally extraordinarily powerful. So, a lot of people never think about it, but, today Ethereum is very expensive. I mean, there's the website out there that gives you the cost of 1 gigabyte of smart contract data on Ethereum. And just today, I mean, it goes up and down. It's like $500 million. $500 million. On Amazon Web Services, I don't know. My guess is it's about 50 cents a year.
Yeah, if that.
Yeah, so that's a billion. It's $1 billion times cheaper. So you've got to ask yourself, well, if Amazon Web Services is $1 billion times cheaper than Ethereum, why is all the DeFi on Ethereum? Well, the answer is that you can only build DeFi with smart contracts.
Programmability.
And also one of the advantages of having all the smart contracts on the same chain is that they can all interact with each other. So, the internet computer is a blockchain, and internally, of course, it scales out by adding subnet blockchains, but that's completely transparent to the smart contracts. The internet computer is unique in providing that. It's a single blockchain. These subnet blockchains act as a single blockchain because of chain. They're able to do that because of chain key cryptography, right? So, and there's a bunch of other things like smart contracts on the internet computer actually run using the actor model and can be run in parallel, which obviously, if you think about it, is another prerequisite for scaling. But, there's a lot of advanced technology involved, but the purpose of the internet computer is to provide people with a single public blockchain, a single general purpose public blockchain, which runs smart contracts. And, we're blockchain maximalists, so we really don't like a lot of the ways things tend to work today. We think it's a bit of a fakery going on. Like, for us, Web 3.0 means running things from blockchain, right? But,
Yes.
What percentage of dApps would you say today outside the internet computer ecosystem run from blockchain?
Maybe 2%.
Yeah, it's actually 0%, right?
Yeah.
Because all of them, So all of them actually, none of the existing blockchains, other than the internet computer, can actually enable their smart contracts to serve web experiences to users. So, in practice, the dApps aren't really dApps. I mean, a dApp is a decentralized application, right? They're certainly not Web3. You might call them blockchain applications. Basically, everything lives on the corporate cloud, right? On a corporate cloud service like, Amazon Web Services. You've got a website that runs on Amazon Web Services. That basically does most of the data processing and stores most of the data involved. And then, does a bit of back-end interaction with some blockchain. And, for example, if you're buying an NFT, the NFT lives on the cloud service, and then just the fingerprint is put on the blockchain. And then when you want to authenticate yourself to the blockchain to actually make it, to perform a smart contract computation, say, you're typically interacting with a wallet that is a browser extension like MetaMask. And where does that come from? It comes from the Chrome Web Store, right?
Yeah.
If there was a malicious Google employee, he could just tweak the code and steal all your ether or whatever it was, And they could also switch it off. In fact, going back a little while, I think to 2018, the Chrome Web Store did indeed ban MetaMask for a short while. So it's not censorship resistant. And you really have to trust Google hasn't tampered with the code. You have to trust that the website running on Amazon Web Services hasn't been hacked. And you have to trust, of course, that Amazon Web Services doesn't want to switch you off. Last year, during the election, Amazon Web Services took against this social media service called Parler. Now, you may or may not agree with the politics of Parler, and it's probably fair to say Jeff Bezos didn't vote for Donald Trump. But, I couldn't vote anywhere. I'm in Zurich now, but when I couldn't vote as a British citizen without a green card. But the point is, it doesn't matter whether or not you'd vote for Donald Trump, right? I mean, Parler should not have been shut down. It's absolutely terrifying that Amazon Web Services were able to push a button. Today, other than dApps on the internet computer, which really are dApps and really, are working in the mode of Web3, 100% of dApps aren't dApps. They're blockchain applications. They're websites running on Amazon Web Services. And they rely on their goodwill just as, people rely on the goodwill of the Chrome Web Store to serve their MetaMask wallet, whatever it is. And look, it wouldn't take much, a change in the regulatory environment, a change in the regulatory, commercial, and political incentives. And Amazon could just say, hey, no dApps on our platform. They could press a button and all of those dApps would disappear, just like that. And you also got to trust, what's even more scary is, that's another topic altogether. If you look at all these new, blockchains that are being spun up in the proof of stake space, I mean, it's just a rush to make money, right? And monetize and sell tokens. And the whole sort of blockchain ecosystem is really like the Matrix, right? It's designed to make people buy these dodgy coins. But, if you look at Avalanche, Solana, well, Solana's is even questionable whether it's a blockchain, to be honest. But Cardano, Polkadot, you go to their websites and you'll go through the documentation, you'll find instructions how to set up their nodes on Amazon Web Services. So they claim this massive decentralization, and it's true that a lot of people are running these nodes. But the reality is, they're just one big node because they're running on Amazon Web Services. Amazon Web Services can steal their validator keys, take control of the chain, or more likely it wouldn't want to get sued by doing that. It would just say, sorry, no blockchain, switch them off. So this is a really, really big problem today. So, we want to make sure that, first of all, the internet computer doesn't run on cloud, and it runs on a sovereign network of dedicated hardware. Like, you need these special node machines, and they're run by independent owner-operators from independent data centers in different geographies and jurisdictions. No cloud involved. And in addition to that, the blockchain itself needs to serve interactive web content, directly to the end user with no cloud being involved. So it can't be switched off, it can't be hacked. And there's another much more subtle piece to it as well, which is that we're beginning to see this already. Like, if you create a faked app, right, the developers end up being sort of transitively liable for the smart contracts. So even like if you look at a service like Uniswap, which is the biggest DeFi service on Ethereum, that's actually, the smart contracts involved are actually upgraded using governance tokens. So the actual sort of DeFi infrastructure of Uniswap is actually pretty well decentralized. I mean, the governance mechanism isn't very sophisticated. Look, it's decentralized, right? The problem is that how do people interact with Uniswap? The answer is by a website and Amazon Web Services, or if not that, a private server or something. And who's running that? Who's running that centralized infrastructure that allows users to interact? Guess what? The developers of Uniswap, right? They're paying, it's their personal credit card or company credit card, and that's being used to pay the service. So the problem is that they realize that even though the smart contracts running Uniswap are decentralized, transitively, they're legally liable, right? Mm-hmm. And it's not really decentralized, and it's very easy for a regulator to look at it and say, well, hold on a second. Really, what I'm looking at here is a website and Amazon Web Services that on the back end makes them, interacts with smart contracts. Even though in this case, it's not so clear cut because they've got some governance tokens that upgrade the contracts. But that's why they self-censored, right? Uniswap self-censored and removed 100 tokens from the DeFi service. And I think that's just, giving you, yeah. So that's, I think, just a harbinger of the kind of stuff that's going to come. So, although it's, little, well, which is funny because, the internet computer is the biggest team in blockchain, right? With all of the most interesting technology, really. But it's not well known that this is the situation that exists. And that if you want to actually create a Web3 dApp that's really a decentralized application that runs from blockchain, there's only one place you can do it. It's the internet computer. Smart contracts on the internet computer run at web speed, and they're incredibly efficient. They can scale out their capacity. The internet computer itself can scale out its capacity. And not only that, those smart contracts can serve web directly into the browser securely using some, again, advanced cryptography, and allowing the user to basically interact directly with smart contracts and authenticate themselves using something called internet identity, which is things that allows you to use cryptographic devices like the fingerprint sensor on your laptop or the Face ID on your phone or a portable HSM like a YubiKey or a Ledger wallet.
And as I understand it as well, since we're heading down this road here, on the internet computer, you can go ahead and deploy something like Uniswap and then natively deploy even the governance tokens as well? Is that
yes.
Something that's in the future?
I think people are already doing DeFi. I mean, we've so there's a bunch of differences between the internet computer and a traditional blockchain. One of them is that the blockchain has this governance system integrated into its protocols. It's called the network nervous system, right? And you participate in that using the ICP token, and you can stake them inside the governance token to create something called a voting neuron. Obviously, the more you stake, the greater your voting power. But when you stake, you have to configure a lockup period, right, or a minimum time, if you like,
of course, which
it will take to recover to dissolve the neuron. And the longer that period is, again, the greater your voting power. The greater your voting power, naturally, the greater your voting rewards, right? So anyway, what's cool about this network nervous system is it's completely permissionless. Anybody can submit proposals to it, and the proposals are either processed by this thing, it's algorithmic, and this thing is responding to the voting activity of neurons. They're called neurons, of course, because you can configure them to vote automatically by following other neurons. And then this network nervous system, responds to the activity of these voting neurons by either rejecting or adopting proposals. And when the proposal's adopted, it's completely, it's executed automatically by the network. And in fact, it's already processed thousands of proposals in the 6 months the internet computer's been live. And these proposals also do things like, upgrade the protocol by updating the software running on node machines, tweaking economic parameters, that kind of thing. So it's constantly the internet computer's a blockchain network that's constantly evolving and improving, and there's a huge number of people working on it all the time. And so there isn't really the concept of a hard fork. The hard fork only occurs in very extreme technical circumstances. It actually happened once, a couple of weeks after it first launched. There was a problem with the network nervous system. The network nervous system couldn't, process proposals anymore. So there's no way of updating it to fix the problem. So actually, all these node operators had to go around and install software manually by sticking USB keys into the back of node machines. But it's only happened once. In normal operation, the internet computer blockchain never needs a hard fork, and it just constantly updates itself through this governance system.
Well, it's kind of ironic because that's really the way that the internet kind of started. Because I know that there are a couple of other crypto players in the space that are trying to do similar, real, true decentralization. And when I've been in those spaces, it's not just once, like you're saying. It's, oh man, we've got to pass out this file to every single developer and every person, every node. So
it's nuts. Yeah, it's not. So I realized I didn't answer your question properly. Your question was, can people deploy Uniswap? So the answer to that, anyways, is some of the functionality needed for DeFi hasn't been switched on in the internet computer yet, and it's going to be switched on absolutely imminently. But there are various other work going on with. I won't even bore you with it, but process separation for WASM runtimes. Because it uses the WebAssembly virtual machine to guard against jailbreaks. And side channel attacks. And so basically, there's a lot of people clamoring for it, allow us to do DeFi right now on the internet computer. And it's a difficult decision because, in practice, the internet computer is a hell of a lot more secure than every other blockchain. It's seriously well built. But the fact is we employ a lot of cryptographers. Cryptographers don't like things going wrong under any circumstances. So we've made the decision just to sort of hold back and wait for this, process separation, which guards against WASM, WebAssembly jailbreaks and things like that. But so at the moment, you couldn't. It's not quite true. You can do some things, and there are already people doing DeFi. There's all kinds of NFT stuff. Obviously, you can move ICP around the governance token and trade that, and you can also move cycles around. But individual smart contracts we call them canister smart contracts on the internet computer. There's some functionality that hasn't been activated yet. It'll come soon. But yeah, absolutely. You could very, very shortly, just create a DEX, for example, that runs on the internet computer. And what you would do is you design it so the smart contracts serve the interactive web content, right? So, obviously, if you go to a centralized exchange like Coinbase, that's probably coming off Amazon Web Services or its own servers, right? If you created a DEX on the internet computer, you'd be interacting with web content that was directly served by the smart contracts themselves without any intermediaries. Now, that obviously is a very important part of decentralization. Like if you want to create a truly decentralized exchange, you need to do that because otherwise you become responsible for creating this exchange. If it really runs on Amazon Web Services, right? You become legally liable. So you could do that on the internet computer today. There's one final step that's very, very important that's coming, which is that you want to decentralize control of the smart contracts behind the service, right? And I mentioned that the internet computer blockchain itself runs under the control of this thing called the network nervous system, which is like a sort of very advanced DAO, decentralized autonomous organization, right? Mm-hmm. That same technology, which has successfully been running the internet computer now for 6 months, and has been developed over quite a long period of time, obviously, that's going to be made available to dApps. So you'll be able to take a dApp like a DEX or a decentralized service or whatever it is, and assign control to a turnkey service nervous system. So basically, you get your own network nervous system. It's the same technology. And once you've done that, the idea is that the dApp or service runs under the control of the community rather than you. So if you're a developer, what you do, let's say you're a DeFi guy and you wanted to create super cool DEX, and obviously some very interesting things are going to be possible soon. There's going to be all these governance tokens for these different dApps running on the internet computer, and plus you're going to have Bitcoin, on the chain and stuff like that. So you build this DEX using smart contracts on the internet computer. There's no need for the use of Amazon Web Services. The smart contracts can serve the interactive web experience. But you're still not really censorship resistant, because you, Mr. Developer, are updating these smart contracts, and the regulator can say, "Hey, you, Casey, you're updating these smart contracts." So the point being that
they can come after you.
They go to you. So you'd assign control of this thing you'd built to a service nervous system. Now, what does the service nervous system do? It creates a new ledger of governance tokens, which are equivalent, again, using the same technology as ICP, which also means that if your dApp gets really popular, the likes of Coinbase and Binance and so on can just integrate your governance token by pressing a button. Your service nervous system, will create 1 billion governance tokens on that ledger. It will then auction a very large proportion of them in a single clearing price auction, so that the participants in that auction receive a mixture of governance tokens pre-installed as neurons, and some of them liquid, mostly pre-installed as neurons. And immediately it's now running as a fully decentralized service under the control of the community, thousands of anonymous neuron holders. And then, the service nervous system will typically, grant some tranche of governance tokens, again, mostly as voting neurons, some, pre-installed in the governance system, pre-staked, and then some liquid, to the developers, the founding team. And then the founding team continues, that's their reward, if you like, for their initial contribution, and they continue as a sort of leading contributor, community member. Obviously, they're very highly incentivized. But the funds from the decentralization auction never go to the developer. They stay inside the service nervous system and are basically, used for things like developer grants, feature bounties, bug bounties, and paying for computation. But they're under the control of the community. So it's not an ICO where the developers go and sell a bunch of tokens and get the funds and can run off. The community keeps the funds. And then typically you will also reserve some tranche of these governance tokens to give out to users. So what we're going to see is this kind of, what's the word, merger of different fields where social media is going to merge with DeFi, games are going to merge with DeFi, and we're going to see social-fi and GameFi. So, for example, there's already a chat service running from the Internet Computer blockchain called OpenChat. If anyone's interested in it, they can find it at oc.app. And when you put oc.app into your browser, you'll see that it redirects you to this really weird-looking address. And OpenChat's being served directly from the smart contracts. Now, once that fully decentralizes, right, you're going to see that your chat account, right, which is actually going to be backed by an individual smart contract, is going to also be a wallet. It's going to be a wallet, right? So, the chat of the future is, your chat account of the future is also your crypto wallet. So if you and I are chatting, right, I can send you tokens inside chat messages. We can negotiate for an NFT, and there'll be an atomic swap executed through chat messages. Obviously, it will also do other, it'll also be possible to do other things like, notarizing documents and doing signing documents in sort of role of DocuSign-esque functionality.
I was going to get into exactly why I was looking through some of the documentation here and exactly why there's going to be a location verification. And I guess the answer to that is that we don't want bots kind of setting these things up and, just kind of...
Oh, I'm not sure. Yeah, no, I mean, look, currently, it's a big misunderstanding. Internet identity is an anonymizing blockchain authentication service. So, blockchain internet identity, is basically powered by chain key cryptography, right? Mm-hmm. And it's designed to allow you to authenticate in an anonymous way and to prevent you being tracked across your use of different dApps. So this, firstly, very important that listeners know that. So there's been a lot of FUD and nonsense on social media. Right? There's a lot of blockchain interests that are very upset about the internet computer. And, we've literally got teams of hundreds of people out there just spreading complete lies. So internet identity is an anonymizing blockchain authentication system. And what happens is you're able to create any number of internet identity anchors, right? And to an anchor, you can assign any number of cryptographically enabled devices. So, for example, I've got an anchor I use with social media, and I've assigned my fingerprint sensor on my MacBook Pro, Face ID on my phone, and I've backed it up onto a YubiKey. And then, if you're using an internet identity with, say, DeFi, you want it to be more secure, then maybe you don't use the Face ID. You use like a Ledger wallet which can, you have to, when you want to authenticate, you have to put the PIN in. But the point is, I can, for example, log into OpenChat on my phone, and I can also log into OpenChat from my laptop to the same account using different devices. If I go to oc.app on my phone, I do Face ID. Right, and that activates a biometric system that causes a private key kept inside a secure TPM. It can't be taken outside the chip to sign a session, right, that enables me to interact with the OpenChat dApp. And something similar happens on the laptop when I press the fingerprint sensor. So I can I can authenticate on any of my devices in a very straightforward way. Now, what's interesting is, I'm using this internet identity anchor for social media, right? So I'm authenticating to, say, OpenChat using my fingerprint sensor, my Face ID, or whatever, or my YubiKey if I want, whatever I'm using. If I go to another dApp like District, right, which is like a professional network that's being built on the internet computer, I can log in exactly the same way with the fingerprint sensor and my Face ID, but both OpenChat and District see different pseudonyms. They don't see the original. The actual internet identity anchor is just a short number, like a phone number you can memorize, right, to reconnect with it. But the dApps themselves see something completely different, a pseudonym. So it's not possible to track you across your usage of dApps. So first of all, they're important to us that people are able to maintain their privacy, and you would expect that to be the case when you look at the people that work for the DFINITY Foundation. And that's not, of course, the case today on normal blockchains. On normal blockchains, you can be tracked across all the different dApps you use and so on and so forth. Not the case on the internet computer, first of all. And that's the fun. You start off from a position where there's total privacy and obviously cryptographic security, although with our case in a much more decentralized way. You don't need any browser extensions or anything, right? You're just using your own devices. Yeah. So always with the internet computer, always real web 3.0. Now you talk about, I think what you're alluding to is people parties. So
that's what I was getting
Yes. So people parties are, no, it's not about location at all. It's not about location. It's also about anonymity. So one of the problems when you have a totally decentralized ecosystem where everyone's anonymous is that, some people will start being trolls.
Oh, of course.
Right. So at the moment, it's very frustrating. There's a lot of blockchains that are really terrified of the internet computer. So for the most part, there's like a crypto media blackout. After we launched, all this revolutionary stuff started happening, and it was a total 5-month news blackout. It was extraordinary. And all you got was just all this madness on social media. One of the other kind of things to give you an idea of the stuff we have to deal with, one of the blockchains, a competitive blockchain, has basically hired this small troll army, right? And this troll army logs in to services running on the internet computer like District and just posts junk content, just nonstop. Like if you post something, you'll get loads of junk comments. And at first we thought it was bots. But it's not. Even if you put a capture in, it doesn't work because they're human beings, right? Being paid by someone. So, that's all right. Okay. Other blockchains are rightfully terrified of the internet computer and its capabilities, and they want to slow it down, and they don't want to see SocialFi and GameFi taken off. So they're going to hire these bot armies. In a way, it's good because that's how you get stronger, right? So the people parties are being brought in to allow people who are anonymous to get elevated trust privileges by proving they're human beings and making commitments to the ecosystem, right? So what we've got coming are people parties. They're completely optional, right? And this is completely virtual. These run virtually, which is quite revolutionary. Essentially, you're going to be able to sign up to this thing, make a small deposit to make sure you attend. Won't be that much. It'll be easily affordable by everyone in the world. And you'll be able to, you basically RSVP for the People Party. When you do that, you have to commit to a location, right? And then when the People Party takes place about 3 days later, essentially you'll be on video with a small group of people who are in your continent, right? And it'll be a small group, and you need to basically verify each of the people in that party are where they claim to be. Without going into, again, all the gory details, all these parties take place simultaneously. And because you as an individual can't be in two places at once, you can only prove personhood once. But we're actually going to run, as we sort of refine the process, we're going to run a succession of these people parties. And what's really exciting is, firstly, every time you do that, you're going to be able to increase the trust associated. You're going to be able to prove personhood, and you're going to be able to use that within services like OpenChat and District. So, for example, you as somebody with elevated trust, you're going to be able to see one of these really annoying trolls employed by competitive blockchains and just, press mute, right? Mute them, right? And if enough people with elevated trust privileges press mute, then the troll is frozen for 6 hours. He comes back, happens again. Next time he's frozen for 12 hours. Next time for 24 hours. So basically that's one of the reasons for it. Another reason is, so that's, a solution that's coming. It's going to be very exciting. I think we're hopefully people are racing to get this done. Hopefully we're going to see people parties taking place in a few weeks. That's super exciting. There's another reason, apart from getting elevated trust privileges, people should want to prove personhood. And that is, you can boost a neuron. So one of the things we struggle with, I think all blockchains struggle with this to some extent, is the power of whales, right? And I'm a whale, right? I'm a founder of the project. I've got a ton of ICP, but there's lots of people who participate. I participated in Seed. I put all my crypto into it, and I've got ICP through other routes too. And there are some big players in that 2017 Seed round, and of course they got a ton of ICP. Now, bully to them, well done. You took a huge risk and it paid off. But, I think, often in crypto, we talk about ideas like, universal wage. And we don't want to create, if you want to create a real Web3, decentralized ecosystem, you don't want it dominated by whales, right? Mm-hmm. And that also goes for the network nervous system, right? There's a lot of whales, who keep a lot of ICP in the network nervous system. And there's like $10 billion locked in there at the moment. And they're getting these great voting rewards again. Brilliant. Thank you for securing the network. Thank you for securing the network, and so on. But what we'd like to do is increase the voting power and economic power of real human beings, right? Mm-hmm. Now, obviously, we don't want to turn this into a sort of universal wage system where, like, this guy locks up, $10 million in his neuron, and he gets the same voting rewards as this guy who's only locked up, $1,000. That would be absurd, right? I mean, yeah. we still want the whales to lend us their capital and to lock up vast amounts of ICP and secure the network and eventually invest it, help invest into the ecosystem. But we also want to balance that by giving more voting power to individual human beings and also more voting rewards to recognize the fact that they are indeed an individual human being that's participating. So these people, if you participate in a people party, on the one hand, you can increase the trust rating you have in services like District and OpenChat and many, many others. Discover probably will do it. On the other hand, though, you're going to be able to increase your voting power and voting rewards. So essentially, when you prove personhood, you're going to be able to boost a neuron in the network nervous system, right? So I don't know the details yet, it hasn't been decided, but let's just say you've got 10 ICP inside a neuron in the network nervous system. You could boost it, and now all of a sudden you've got the same voting power, and that means voting rewards as if you had 50 ICP locked inside your neuron. Obviously, there's going to be some limit. You're not going to be able to boost it beyond, right?
Yeah.
If you have if you've got 1,000 ICP, you're not going to be able to boost it, right? Because you're probably getting onto being a bit of a, not quite a whale, but you know what I mean. But yeah, we want to make sure that like every individual can, who has a modest amount of ICP and they're participating in the network nervous system, they can basically boost their voting power, right? In consideration of the fact they're actually a human being, right, with their own brain, right, and also increase their voting rewards. So I think it's going to be pretty exciting. And I don't know, we're going to keep on running these again and again, right, until we get the People Party thing right. And every single time that somebody participates, they're going to be able to increase the trust rating of that they have as an anonymous person, and also boost more neurons. Now, we don't know how many people will participate. I think the first iterations are going to have to limit the numbers of people. It's going to be fully decentralized there. It's all going to be run by smart contracts, no cloud or anything like that involved. But I think that the smart contracts will have to limit participation initially, because we don't know how many people. It might be only 100 sort of decentralization fanatics actually turn up. Who knows? Maybe it's just me on my own or something. But there's a big possibility that actually we get some thousands even in the first one. So we probably have to limit participation, in which case it'll do it like a lottery or something to decide who can take part. But we plan to scale it up and hopefully have millions and millions of people taking part in these people parties. And the system does that, right? Because what it's doing is it's randomly sorting everyone into individual virtual parties, and people don't have to, in fact, it's very important that people aren't in the same place, right? And to be clear, it's true that when you RSVP, you do have to commit to a location. And then when you participate in the People Party, you have to show you're actually there. That's not because we're trying to track, or the systems involved are trying to track anybody or associate people with a location. It's simply because that's the only way that's what enables people to prove that they're actually a real person in one location, because you can't be in two places at once. But the smart contracts will delete that data after the People Party's run. It's not a purpose like you proved it wouldn't mean anything anyways, because I could be in Amsterdam one day and do my People Party there and come back here to Zurich. So it wouldn't provide any useful information anyway.
Sure, of course. So the People Party is trying to solve that problem of that community moderation that we haven't really figured out in a centralized environment. Because I know that one of the biggest websites in the world doesn't even pay their moderators. So
that's right. So you got to think about it like Les. Like, we think, we proceed in very structured ways, as you'd expect, because, we're very science and engineering driven. So, the first problem we had to solve was enabling people to, authenticate themselves to blockchain dApps and services using cryptographically enabled devices like the fingerprint sensor, Face ID, YubiKey, Ledger Wallet, whatever, in a way that kept them anonymous, right? So, the actual private keys exist inside these TPM chips, and they're only used in conjunction with internet identity. So it's not, we're not like, the internet identity doesn't know about somebody's device. That's another misconception. People hear that you authenticate yourself using your devices with internet identity, and you hear all this mad stuff on social media saying, oh yeah, when you get internet identity, all your devices, a link to all your devices is stored on the blockchain, right? And they're tracking. Of course not. Like, it uses a protocol called WebAuthn, right? And basically, for use with internet identity only, a key pair is created inside a special chip on your computer or your laptop, or inside a secure element or a Ledger Wallet or something, and it's only used with internet identity. It's a key pair that lives there, that's separate to every other key pair. So internet identity allows you to authenticate using your devices, but it doesn't identify your devices to internet identity. Of course not, right? It's an anonymizing system. And not only that, when you go between different dApps in the internet computer ecosystem, they're all seeing different pseudonyms. So that's layer one, right? Enable people to authenticate anonymously and securely using cryptography with the minimum of friction, right? And you probably agree with me that pressing the fingerprint sensor to get into OpenChat is a minimum of friction. And it's more secure because although it's using cryptography, you're never actually touching the keys yourself, right? Because if you can touch the keys, and you're sort of backing them up by sending yourself a chat message or something like that, they can be stolen. Okay, so we've got this layer 1, which is, anonymizing and very convenient to use and highly secure. Okay, layer 2 is we just want to be able to, identify, grant things to people because it is an anonymous universe that can say, I'm a human being, I'm a single individual, right? And there's going to be this personhood profile thing that you can create. And people can actually create multiple personhood profiles, just to be clear, but there are advantages to topping up the trust in just one. And, that means that we can, boost the voting power of, actual real people, right? And increase the rewards they receive, which is more democratic, which I think everyone in decentralization and blockchain can agree is a worthy aim. And then, the third layer, which is probably going to have to wait a while because we're kind of snowed under, is property-based identity, which relies, again, upon advanced cryptography. In fact, Jan Kamenisch, our CTO, was the guy really who invented this, at Sovereign, and showed how you could do this efficiently with zero-knowledge proofs based on BLS and things like that. So essentially, that's going to enable you to collect attestations, right? And once you've collected these attestations, you can prove things anonymously to people. I could prove to you that I'm over 21. Sadly, I could prove to you I'm over a much bigger age, right? But let's say I was getting into a nightclub, right? I was going to a nightclub. You could be the bouncer, right? You could be the bouncer, and you'd have like a phone, and I would walk up to you with my phone. They'd communicate by near field, communication, right? Mm-hmm. And, you would see my picture with a tick saying over 21, right? And so you as the bouncer, this dude in this picture, which is him in front of me, is over 21. But I would have convinced you of that in zero knowledge, right? Without ever having to give you my driver's license, say, or something like that. So, that's a very simple application, but, you can imagine reverse mortgage markets where as an individual, you can participate in the reverse mortgage market and, prove you're a citizen of some country, you've got a job that pays so much, you've got a house that's worth so much, there's, an existing mortgage of so much, and so on and so forth. And you can go to this mortgage market and say, hey, give me mortgage quotes, refinancing quotes or something like that. And, the people involved in, the mortgage brokers, if you like, or the mortgage companies involved in that market can be convinced of all of the salient facts, right, that they need to give you a quote, but they don't know anything about you. They don't know your name, address, or anything like that. And then you can introduce rules and, that you can only participate so many times without accepting a quote and so on and so forth. So, that's called property-based identity. So, we're approaching it in a very structured way. At the bottom layer, you've got internet identity, which is an anonymizing blockchain authentication system where you can, authenticate anonymously with great security and with great convenience because you're just touching the fingerprint sensor or look at your Face ID or something. Now we're adding another component, which is personhood. People can prove they're a human being, an individual human being, and that allows us to, for example, increase the voting power in the network nervous system accruing to that person and give them greater rewards, and allows them to be given elevated privileges in SocialFi, merging SocialFi and GameFi dApps, for example, as moderators that can mute miscreants, employed by other blockchains that are just posting junk day and night. And then that's the second layer. And the third layer that's following is going to be property-based identity. But that, I think we might get it done, halfway through 2022. It's actually quite a complex.
Well, I know that somebody this week just announced the Metaverse, but it sounds like y'all are building the actual building blocks over there that those guys are going to need to depend on. So.
Well, the decentralized Metaverse. So look, this is just what's cool, right? I mean, look, I love NFTs and it's all very, NFTs are great and everything. And but blockchain is going to become about much more than just like, a picture you can buy and sell, right? Collectibles. Blockchain is going to become the final stack. right? On the internet computer, you can build entire systems end to end from smart contracts. You don't need the corporate cloud. Like, the internet computer is the final stack, and or is designed as such. Maybe we'll fail on some, but someone's going to do it, right? And the aim is obviously to have all of humanity's information systems, rebuilt using smart contracts. But when that happens, they get reimagined. Like, DeFi is built with smart contracts, and so it makes use of new capabilities and looks very different to traditional finance. Now, if you look at OpenChat, for example, it looks very much like WhatsApp, although I believe there's this update coming in a couple of weeks that's going to change the way it looks. But the point is that it's not just about trying to replicate WhatsApp on blockchain, on the internet computer. That's table stakes. You've got to replicate the basic functionality running entirely from blockchain just to get moving, right? But, established tech has these immense network effects, just like traditional finance has immense network effects. And you need to use the power of tokenization to win and to overcome those network effects. So, sorry to keep using OpenChat as an example, but I think it's a good way of explaining it. What you're going to see when they fully decentralize and run decentralization auctions, probably in January, is the introduction of advanced tokenization. Your blockchain chat account is also a crypto wallet, and you can send Bitcoin with a chat message, right? Which is obviously one of the exciting things that's coming with the Bitcoin integration, and do other things like negotiate for NFTs and do atomic swaps and sign documents and notarize documents. You sort of need this. You need this just single unified Web3 environment to pull all that stuff off.
Yeah, and it would be
GameFi is the other one. GameFi, you're going to see play to earn, right? And you can't do this stuff. Like, for example, if you believe like me in decentralization, then you believe that the next generation of social media and GameFi will make the users, the owners, and the team, right? So let's think about OpenChat, right? But it's prototypical for any social fi service. It's going to start probably randomly airdropping algorithmically, right? Not an airdrop in the traditional sense, but the actual smart contracts themselves are going to start giving out, governance tokens to users that are actually online, right? So let's say you're online, it's going to say, hey, complete this captcha to prove you're not a bot. Okay, well done. Here's 3 governance tokens. At some random time, you never know when it's going to happen. So if you're not online, obviously you're missing out. Hey, man, prove you're not a bot by doing this captcha, and you get next time like 6 governance tokens. And so the point is that people, through that kind of approach, you can ensure people are online all the time, which obviously is very important when you're building a social media service. You want people to be online so they can interact. But by making users the owners, you're also making them part of the team, the business development team, because they're going to go out and tell their friends about it and say, hey, come and get an OpenChat account. You can get these governance tokens, right, by being online. So they're going to become advocates. That's kind of what happens with blockchain now, right? People advocate for the blockchains they're invested in. But it's more than that too. That's one, in a sense, the users will become the owners, and the business development team and the moderation team, right? The users are the future owners and the team. Now, of course, within that mix, you're also going to get investors who acquire these governance tokens, either as individuals or venture capital firms or hedge funds. And you're going to get, the developers that build out these services who are going to be incentivized with tokens too. But they're just going to look very, very different to the services of today. And that's what's so exciting. It's social-fi and GameFi that's going to bring in billions of users to blockchain. That really is where this is going.
Well, yeah, because I can almost instantaneously take a line from where we are today to the things that you're describing with GameFi and all this other social-fi. We could take things like, Web Turks, those repetitive kinds of things, and turn that into GameFi with these things that it seems like y'all are building.
Yeah, totally. And you mentioned the metaverse. I think I tend to go off on these tangents, but back to your original question. Sorry. You mentioned the metaverse and Facebook and so on. I'm sure Meta is going to be horribly successful, but God help us, right? That everyone's sort of floating around inside Facebook's walled garden. This is not where we wanted to go. The metaverse needs to, be built on blockchain, and it needs to, make things like, cryptocurrencies, NFTs interoperable. So, I can be in one virtual world. I mean, by the way, the internet computer runs WebAssembly. Smart contracts are like a bundle of WebAssembly and persistent memory pages. If you heard of Unity, Unity is one of the biggest game engines in the world, right? Unity now will compile down to WebAssembly, so you can run it in the browser. So you can have end-to-end WebAssembly. Yeah, it's going to be epic, right? The point is, you can be in a 3D world, right? Served into your browser. Basically, it's WebAssembly compiled from, down from some Unity app, and it's interacting, with more WebAssembly on the internet computer blockchain, right? And you could be in this three-dimensional world, right? And no doubt there's ways of getting out the browser full screen and connecting it to virtual reality goggles and all the rest of it. But what's important though with this is it's completely open, and the developers can, introduce cryptocurrencies into that space, NFTs into that space, and imagine this. We've just talked about OpenChat, and the fact that OpenChat is not only a messaging platform, but also is going to do all this other stuff like, be a cryptocurrency wallet, enable you to send cryptocurrency or chat messages, sign documents, negotiate for NFTs. Well, guess what? Let's say someone builds a GameFi game, right? End-to-end WebAssembly. They use Unity and internet computer smart contracts written in Rust or Motoko, say. And obviously, they introduce cryptocurrencies and things like that, or token, it's fully tokenized. But they could also say, "Oh, we need some chat functionality. We need some chat functionality." Okay, we're going to import OpenChat into our game. Right, and so now you can meet people inside this three-dimensional metaverse and then start chatting. But when you're chatting, you're reusing your existing OpenChat account, say, and you've got all of these tokens available to you and things like that. And not only that, OpenChat itself should be designed in such a way that it's extendable by other blockchain developers, right? So OpenChat really just becomes the sort of nexus of many different smart contract-based systems, which itself now appears within some three-dimensional kind of environment. That to me is the metaverse that we want to see, like an open, permissionless public blockchain where innovation, is free. If anyone can innovate.
So less of a walled garden and more of a park where that guy over there, he built the pond, and that guy paved the road, and that guy planted some plants, and maybe there's somebody that builds Unity or writes Unity, or somebody who's got some WebAssembly experience watching right now. I know we're kind of running out of time here. Y'all have a grant program still going on?
We do. I know we've got a big, and it's going to go on forever. I mean, I'll be honest with you. I mean, the DFINITY Foundation's grants aren't the biggest. Despite all the nonsense on social media that we did some kind of rug pull and we sold billions of dollars of tokens. We actually didn't sell any tokens initially. Right? We're well financed. But we're pretty modest with our grants, except there's a difference here. Our grants program works in a different way. So first of all, the purpose of the grants really is to take you to a decentralization auction. Right. So, we give out grants, and, the aim of the grants is to fund people to get to that place. And not only that, we give follow-on grants. So what we tend to do, rather than trying to, we don't want to be discriminatory, right? We don't want to be like because what you're tending to see already with other blockchains is you're just getting all the usual suspects getting these big grants, right? They're like teams out of Silicon Valley that are connected to venture capitalists. We prefer a much more sort of organic approach, right? Where it's much easier to get a grant initially. And then if you need more money to get to a decentralization auction, we'll give you a follow-on grant based upon progress that's demonstrated, right? So the modus operandi is pretty much, hey, you want to get a grant to get going, here you go, right? If you can't get to a decentralization auction from this, come back to us. And if you can demonstrate progress, we'll give you another one. But the aim for everyone, in our view, should be to get to a decentralization auction where you can hand over control of your SocialFi, GameFi, DApp or service to a service nervous system, which is like a sort of DAO. And that thing then runs a decentralization auction in which it auctions governance tokens to the public and runs under the control of the community thereafter. And you obviously probably very likely still lead the community as a primary contributor. But we believe we're going to see. I think there's like 50 plus dApps already planning to do this in January when this functionality goes live. Who knows how many will be ready by then? I think we're going to see, much larger amounts of money raised in this way, directly into decentralized autonomous organizations, right, that run autonomously and control these dApps and services. Today everyone's like, if you look at the crypto media, it's like, I'm not talking about these dApps unless you tell me that they've raised $10 million in grants from some foundation and from venture capital. And it's kind of like, I just hit my head. I'm like, this is meant to be Web3 for crying out loud, right? Why are you obsessed with dApps that raise money from foundations and venture capital? What should matter is, what are these dApps doing? What's the functionality provided? What's the experience? And most importantly, what's their decentralization plan? Like, how does this really work within this new ecosystem, this true Web3 ecosystem we're trying to get to? But I think they're going to start listening anyway early next year. My prediction is that these fully decentralized Web3 dApps and services are going to raise vastly more money than these teams that have chosen to take the venture capital pill. By the way, the venture capital is still incredibly important. I would urge every single venture capitalist out there to get involved with the internet computer ecosystem. And you can fund, very, very cool teams working on the cutting edge of blockchain. And when, if you help fund those teams, when they run decentralization auctions, you can have a slice of their founder tokens. This is exactly how blockchains like the internet computer were funded originally back in the day. So, dApps are becoming like blockchains themselves. Really, once you run under the control of a service nervous system, you're really becoming an extension of the blockchain yourself and creating a microeconomy within its macroeconomy. But that's the important point. You're becoming part of an extension of the blockchain, and that's why you can do advanced tokenization. And these things are going to go huge. And, VCs, it's definitely going to be a very fertile ground for VCs. But the important point, though, is that the aim is to decentralize, right, rather than be centralized, because it's only through true decentralization that you gain the freedom to do things like, socialify and gamify that will basically merge social media functionality with DeFi functionality, or game functionality with DeFi functionality. If you try doing that on Amazon Web Services, you'll get away with it for a bit, and then sooner or later you're going to get in trouble and be self-censoring like Uniswap. Anyone out there that's excited about blockchain, check out the internet computer.
Awesome. Well, thank you so much, Mr. Dominic Williams.
Thank you.
Chief scientist and founder over at DFINITY Foundation. They're working on the internet computer, which is building true decentralized Web 3.0 apps and empowering the community to do its own moderation and, get a little bit back for it. So thank you for talking with Reimagine today.
Thank you. Yeah, thank you very much. It's been fun.